We are live. So today I'm going to talk a little about doing calculations in Python. So in this class is basically focused on computational methods with a focus on numerical methods. And by that I mean really what we're going to do is try to learn how to use Python to solve basically any kind of equation you've seen in your undergraduate education. Um, Now, some equations might be a little bit too difficult to solve. Just basically, you're going to ask too much from your laptop. If you think about things like computational fluid dynamics, that's stuff that tends to be solved on supercomputers. So we're going to limit ourselves to a lot simpler problems, but still we're going to solve some sophisticated problems numerically that'll solve in a few milliseconds on your laptop computer, and that includes partial differential equations that don't have analytic solutions. But today we're just going to use Python as basically a simple calculator, and it's kind of a nice feature of it. So here I have a brand new notebook opened up, and let me just show you how to do it. So if I take a cell and I type in a mathematical expression, say 1 plus 1, I type Shift Enter, it's going to give me the answer 2. I can do multiplication. I could do 3 times 6. I'm going to get 18. Or I could do 3 divided by 6, and I'm going to get 0.5. I can also do the power operation. So I could do 3 to the power 2. So that's 3 squared, right? I'm going to get 9. But I could do 3 to the power 5, and I'm going to get 243. Or if I wanted to, I could do the square root of 3, right? Just the power half, and I'm going to get 1.732 and a bunch of extra decimals. I'll talk later about floating point numbers because they'll become important in a second. So we have kind of our basic commands of plus, minus, multiplication, division, and the power operation. So one of the things I have to talk about is order of operations. So if I have the command 1 plus 2 times 3, right? And so you could read this a lot of different ways. So one of the things, if we're just evaluating this left to right, I'm going to take 1, add it to 2, that's going to give me 3, and then I'm going to multiply it by 3, and that's going to give me 9. But what Python's going to do is it's going to evaluate this expression because it's ambiguous. It has to come up with a rule so it knows what to do. And what it's going to do is first evaluate the multiplication and then do the division. So the general rule is it does multiplication, division first, and then it goes addition and subtraction, and again reading it left to right, but starting with the leftmost multiplication. So what Python is going to do is going to take 2 times 3, which is 6, add 1, and that's going to give me 7. Now if I want to force an operation, I can always use parentheses. So if I want that 1 plus 2 to be evaluated first, I can put parentheses around it and then multiply it by 3, and then I'm going to get 9. Same with the power operator. So if I have 2 times 3, 2, right? Power 2, let me do it like that. So the way Python's going to do it is it's first going to evaluate the exponential. So I'm going to do 9, and then I'm going to do 2, and that's going to give me 18, right? So I can see that. I get 18. And if I wanted to get 6 squared, right, 36, I'd have to do these parentheses here, 2 times 3, then take it to the power 2. So I'm going to square it, and I'm going to get 36. In general, I suggest using parentheses as much as possible because it removes ambiguity. Because you may be writing stuff, you may be copying down some equation, and you're going to forget about order of operations. And so this can save you a lot of grief. I spent far too many hours debugging programs where I've messed up the order of operation. But one thing I should emphasize is we can do complicated expressions. So I could do 1 plus 3 to the power 3.4 divided by 1, 2 over 4, 3 times 2 divided by 89, and then I can subtract all this by 1, right? And again, what it's going to do is it's first going to evaluate, actually in this case it's first going to evaluate what's in this parenthesis, the most nested one, and it's going to say, all right, let's do 4 times 2, that's 8, then I'm going to divide it by 89, then I'm going to add 3 to it. And then it's going to evaluate the stuff in here, and so it has 1, but then I have this 2, the multiple divisions first, so it's going to take 2 and divide it by this mess. And then it's going to add 1 and then subtract 1 from it, right? So these are actually going to cancel out over here. And then it's going to take this quantity in the parenthesis sign and divide it. And actually, once it has this done, it's next going to evaluate this power operation. So 3 to the power 3.4. Then it's going to divide it by this mess. And then it's going to add the 1 to it. And then we have kind of, the expression. Here's a case where I'd probably put parentheses around here just to make sure that it's clear that this is being done first and then being divided by that. But anyway, you can see that you can put as complicated expressions in. So it's kind of like a scientific calculator. So one thing also is what happens if we have multiple calculations in the same cell. I mentioned we can have lots of code in a cell. So I can maybe say 1 plus 1, 2 times 2, and maybe I'll do 3 to the power 2. What you're going to find out here is it's only going to print the last expression, right? 3 to the power 2. And then if I have another line of code, maybe if I just say print high, right? It's not even going to print that, right? Because it's just going to get lost. It's only when that expression's on the last line do we get the answer. But if we want to see the expressions for all this, we can always just type print 1 plus 1. We can do print 2 to 2, and then we can print 3 squared. I'll later show you some more tricks with printing numbers. And in this case, we're going to get 2, 4, and 9. So 1 plus 1 is 2. 2 times 2 is 4. And then 3 squared, of course, is 9. So one other nice feature Python has is integer division. So if you think back to probably high school or middle school when you did this, if I want to do integer division, I'm going to do double slash. So normal division, so if I come up here and I do print 5 divided by 2, I'm going to get 2.5. Right? Let me just clear that out. Right? So I have 2.5. Now if I print 5 / 2, what I'm going to get is the answer 2. And then basically what it's saying is that 2 can go into 5 in integer multiples only 2 times. So that would be kind of the integer division. And if I wanted the remainder, I'm going to use this command called the mod operator, which is a percentage sign. And let me just put in a space. I can always put spaces between things here. All right. And what that's going to do is give me the remainder of that operation. So if I did like 11 by 2, right, that's going to give me 5 times. And then let's do it something like 3, right? It's going to go into 3 times into 11. And then here, my remainder is 3, and that's my remainder 2. So that's the integer division, and that's the remainder. You can play lots of tricks with this mod operator, particularly with for loops and kind of doing indexing operations, which we'll talk about a little bit later in class. All right. So one other thing we can do is we can define variables. So let me come down to a new cell. So I can define a variable, and I can set x is equal to 5. And then maybe I can do a y is equal to 3. And then let's take a look at x plus 2 times y. And we're going to get our calculation here that this equal sign is an assignment. So what it's basically saying is let's take this variable x. That's what we want to assign. And then on the right-hand side of the equality is what the value we're going to stick in x. So that means x has the value 5. Here we're sticking 3 into the value y. And so when it evaluates this, it's going to say, hey, I got this x variable. What's its value? So it's going to stick a 5 in here. And then when it sees that y value, it's going to stick that 3 in that value. And you can define lots of different variables. These are just kind of scalar variables. We'll talk about vectors later. But in general, it's good to use descriptive names. So you might say my variable, right? I could do my variable is equal to 10. I can, again, hit the command, and then maybe I can print my variable, and it's going to give me the value 10. So this is like really good, like in your code, like you might have temperature is equal to, maybe it's like 80 degrees, and then pressure is equal to 5. And then maybe we're multiplying, temperature, by pressure, and then we're going to get the answer 400. So variables are really good to use. One extra thing is we can use this notion of list comprehension. So imagine I can write code that x is equal to 1, y is equal to 2, z is equal to 3. And then I can print these, and I can print these again as a list, x, y, z. And so I get 1, 2, 3 for the values of it, right? But, if you're lazy and you want to do this kind of more of as people call it, a Pythonic way, I can say x, comma, y, comma, z is equal to 1, comma, 2, comma, 3. And what it's going to do is say, hey, I got a list here of 3 elements, x, y, z, on the left-hand side. I got a list on the right-hand side of 1, 2, 3, right? And now I can do matched assignments where x is 1, y is 2, z is 3. And then if I print x, y, z, I forgot the last one. That's why I didn't print it. And then I get my 1, 2, 3 here. If I want to change this to 20, of course, I'm going to get 20 in that value. Now, if I try putting an extra element here, a 5, it's going to give me an error. It says too many values to unpack. Expected 3 because I got 3 over here. And then I got 4 all over here. Here's showing me where the error is. This is the first line. Here's the second line. It's pointing, hey, this is where the error is. And in general, when you see this, this is pretty benign error. You're going to get a lot more verbose ones. Just scroll to the bottom and try to figure out what that last command says. That's probably the most useful for determining your variables. So a couple other tricks you can play with this. So if I have x, y, z here, maybe I want to swap x and y. So I could say x, comma, y is equal to y, comma, x, right? And now I'm going to swap the value of x and y. I could also put my z here, and maybe also assign z is equal to 4 times x, right? So here it says x is equal to, so let me go back. So x is initially 1, y is initially 20, z is initially 30. Now I'm saying in this thing, let's set x to y, right? And y was 20, so now x is 20. Y, I'm setting it to x, that initial value, which was 1. And then z, I'm setting to 4 times x. So in general, you can set variables equal to another, right? So we can say, p is equal to, rt all over v, right? That would be a formula, so I could always write this. And maybe, I forget the units here, but, 8.314. And then, my temperature, I got to do Kelvin, so let's do 310. And volume, I don't even know what the units here. Let's assume it's liters. And then I'm going to get some pressure. I forgot to do the print. So I'm going to print P. And then I'm going to get the pressure, and I have no idea what these units are, but you can define formulas this way. So last thing you might wonder is, what about like special functions or transcendental functions like sine and cosine? Here we can actually do, there's no base kind of sine and cosine in Python. So if I came over here and typed sine of 5, right, or sine of 4, it's going to say, hey, sine's not defined. It doesn't know what that is. So what we're going to have to do is we're going to have to import a library. And we're not going to use this. We'll use this library initially, but then we'll transition to another one. But let's import the math library. So I'm going to just hit import math. And then what I can do is, if I want to look at the sine, I can say, maybe print. I have to do math, which is telling me the library, and then I'm going to do the sine. And then this is going to be in radians, so it's going to be sine of 2. And I'm going to get kind of the sine here. In this library, there's also pi, so I could do math.pi, right? And so here it has the constant within the library. So within the math library, what this is saying, let's call the sine method or sine function. And here it's saying within the math library, let's get this constant times pi. And then I run it. And basically, this is effectively 0. This is kind of machine precision 0, and sine of pi is 0. And if I divide it by 2, right, this is going to give me 1, which makes sense. If you want to take a look at what's in your math library, I can come down here. We still have it imported. I can type the command dir math, and it's going to give me all the different functions. So if I come down here, so these are just kind of built-in functions when you see these underscores. but this is the arctangent, arc cosine. This is the inverted one. Ceiling, which is basically, it's kind of a rounding operation. You see the error function, complementary error function. We have infinite, right? When we want to test something infinite, we have pi. We'll talk later about nans, which are not a number. Square root. I don't actually know what remainder does off the top of my head. It's probably like the mod operator. I think radians converts to different things. We'll use a different library later, which I know a lot better, which is the NumPy library. But rather than doing, I actually dislike this syntax, right? So let me clear it out. Like I don't want to type, math of sine.4, right? That's kind of annoying. So what you can also do is if you want to import specific functions, so I can type the command from math, I can say import sine, cosine, and pi. And then maybe I can print the sine of pi, and then I can print the cosine of pi. And I can run these, and I see the sine of pi is 0, and then the cosine of pi is -1, which kind of matches our definitions. Another way to do this, rather than specifying which functions we want from this library. So the nice thing about this, I should say back, is I don't have to put this math.sine there. And so here I can just do sine and cosine. If I'm lazy and I don't remember, like maybe I want to do exponential, like I want to say print, what's the exponential of, let's do the exponential of cosine of 3, right? And it's going to say, hey, exponential is not defined. What I could come back here is I can just do import star. And basically that's going to import all the functions from math. And one of them is, exponential. And now it's going to give me the answer of exponential. Another way of doing this, and then we'll do this a lot when we get to kind of NumPy, which is kind of same as math library, but extended to vectors, is I can import math as m. And then if I want to do sine, I can say print m dot sine of, say, 2. All right. And what it's just doing is coming back to this code up here. Rather than import math and calling it math, I'm just going to call it down here just m. Or I could do, I could call it Chris, which is my name. So I could say Chris.sine, and I'm going to get the same answer. So, sorry to keep on scrolling. Anyway, so that's kind of just a basic overview of a little bit about variables, using kind of basic calculations, using the print statement to print out those comments, understanding that if you have a simple operation at the base of a cell, like if I do 3 times 2, it's going to print the output out there. But if I assign this equal to a variable, I say x is equal to 2 times 2, it's not going to do that, because here the output is, the operation is not just simply nakedly evaluate 2 times 2, it's evaluate 2 times 2 and set it to the value x. And then if I want to print the x value, I will get the x value out of that. So with that, I'll stop. Again, if you have questions or comments, email me, put them in the comment section, post them to Piazza. I have more annotated versions of the code up tomorrow, but stay safe, and all right, bye.